Hello everyone, and welcome to this webinar where we are going to take a look at portal frames. I hope everyone can hear me okay. My name is Flavio. I'm a structural support and sales engineer at StruSoft Denmark. I'm going to be the webinar host today, and hopefully Dennis, my colleague, will join shortly, and he will be taking your questions. As you can see in your GoToWebinar window, you should have a field for questions. Here is where you can type your questions, and hopefully we can get back to you during the webinar. If not, we will take them afterwards and just reply to you via email. So today we are going to make stress calculation in portal frames. Stress calculation and stability analysis in portal frames. To do that, we are going to create portal frames using plain plate. You can draw a plate in fem-design by going to structure and plain plate and draw your plates based on your dimensions. And you can also draw a, which we are going to do today, draw a portal frame, a steel portal frame. So as I was saying, you can draw it by plain plate, or you can also draw after an AutoCAD file, which I'm going to do today. So if you have the drawing in AutoCAD, it is easy to draw it by opening it in fem-design. So I'm just going to go to File, Open, and select .dxf. And this is the file that I want to use. Click OK. And I have my lines here, my AutoCAD file opened in fem-design. So now I can easily actually draw some plates following these lines. To do that, I go to Plate, Plain Plate, and here is where I define my plate. I go to Default Settings and choose the material first. I'm going to do that. Just select steel material S355. Everyone can hear me okay? Yeah, also the chat you can use if good, great. I also have to keep an eye on the window for now. So I'm going to select steel S355 as a material, and I'm going to start drawing the webs. So for my web, I'm just going to say 6.5 millimeters for my web. And I click OK. And really fast will work if I choose thick lines in the tools here. So now I just go ahead and choose the lines that I want to draw my web in. And there I have a plate defining my web. I could go ahead for draw it for this beam as well. Choose the lines. and I have my webs. And I'm going to do the same thing for the flanges. I'm going to choose a different thickness for my flanges. Let's say like that. And just select the lines for my flanges. Yes. And for the last column as well. And I now have 2 columns and 2 beams connecting in the middle. I have my portal frame so far. What I want to do is create a base plate, some base plates for this portal frame. So I'm going to do the same thing. I'm going to draw a plain plate as a base plate. I'm going to choose the rectangular tool to draw this, and I'm going to go down to the base of my frame and start drawing from this point. Enter the coordinates relative to this point. So I'm just going to put it eight centimeters from that corner and 8 from this one. And yes, I need to define a different thickness for my base plate. Of course, I'm not going to let it to be 1 centimeter. Like that, I'm just going to put it three centimeters, let's say. Yes, and I'm going to copy it. Here. Let's see if Dennis has arrived in the chat. Yes, he is, and I'm going to make him an organizer so he can answer questions when you type them in the questions here. So just type any questions you have in the questions field. Okay, so I'm going to continue. I have my base plates so far, and I'm going to first of all, once I've made these steel plates for my steel profiles, I'm going to add these stiff fictitious bars at the end. I'm going to show you how. Just click on fictitious bars, and I'm going to select just this line by selection. And I'm going to put these fictitious bars at the end of my profile. This will ensure that this end will move together as one. So I'm just going to put it Okay. So now I want to have a support for my frame. For that, I'm going to use a surface support group. And I am going to use this in compression only. So I'm going to put free for tension. Okay. And I'm going to select pick existing region and right click on my base plates. So that will act as a compression support. I'm going to also put some point supports to work in tension. That will be my bolts. So to do that, I'm going to choose a point support group and define my settings. First of all, I'm going to put no moment, and then I'm going to allow them in Y, both tension and compression, and set only tension. And that is because I want them to take shear as well. Just going to put them rigid there in tension. And I think that is okay. And I'm just going to place them halfway from my profile to the end of the base plate. So I just put a 4 centimeters. Yes. And put 4 of them. Okay, and I can copy them on the other side. Just a copy and make a multiple selection. Place them right there. So now I have my supports for my frame. What I want to do is define some edge connections. I'm going to define some edge connections for my plates because I want to be able to get the connection forces in those edge connections. So that way I can actually use those forces to design my welds for these corners here. So to do that, I'm going to create a custom edge connection. Let's start with going to plate, plain plate, and choose edge connection. Going to right click on the plate and on the edge connection. And I want it to be rigid, but I don't want it to be this predefined one because this one will not give me connection forces. So I'm just going to make a custom one. Guess edit the library. It's fine. I can just use this one, which I've made before. I just modified instead of 1 times 10 to the power 5, I just put 1.5. This will be viewed as a custom edge connection, but it's still rigid. That way I can get the connection forces. So Click OK. And I do that for my web as well. And for the other flange. And I can do the same for both if I want to. Just gonna leave it like this to get the results for this one. I'm going also to have this one hinged. So just hinged. So not to take a moment. Okay. We can now continue to go and add some loads. Of course, to do that, I go to Loads tab and create some load cases. I'll consider self-weight, which will be structural dead load, so it will be assigned automatically. I will have some vertical load, and some horizontal load. Okay. And let's say I'm going to add some snow load, which will be a line load. Put 4 kilonewton per meter. Just put it on my beams. And then horizontal load acting on the column. Kind of make it like this, 10 kilonewton per meter. So I make it strong enough. Of course, I want it parallel to Y. Make it strong enough so I can get some tension as well in the base of my column. So I have these loads, and I can go ahead and create some load combination. Just one. Self-weight, load, and snow and wind. I have my structure and I have my loads, and I can go ahead and perform a structure analysis. So analysis, calculate, and load combinations. What I am going to look at is the stresses in my plates and my shell model. So if I go to new result, load combinations, shell stresses, and sigma fem max, that's sigma von Mises maximum, and choose the color palette to display it. I'm going to have this stress distribution in my frame. Just increase the scale a little bit. And I can also see some numeric values by going to automatic and global maximum minimum. I just want the maximum. I can see I have a maximum stress here in my corner. So this is what I'm going to check in my plates, in my shell model. I'm going to look for sigma fem max, the maximum stress. I can also check my reactions. So if I go to new result, reactions. And I don't want all of this to be seen here. I just go to display options. I want the surface. I don't want any resultant. Yeah. And no bending moment. No, that's not a bending moment. It's just a value. Just turn this off right now. So I can see here my reactions in the base of the column. I can see here working in compression, my surface support, and then my tension in the bolts. You can also put some values in there. And also the shear forces in my bolts. Yeah, point support groups in this case. So this is a good way to see how this column base is behaving and have this compression distribution and tension in the bolts. As I was saying, we can check for connection forces in my corner connection here. Since I've defined these edge connections, I can get the edge connection results from my analysis. So if I go to new result, connection forces, and customize just these display options. Gonna want any points, just a line, and forces, maybe the resultant. And I can actually go and see a detailed result here for my edge connections. So if I right click on this, I will get my forces in the connection. These are small bending moments. And then I have my forces here. So they can be used to calculate your weldings. just to recap, I have the shell, stresses, sigma, fem, max, which I'm going to look for. My reactions at the base of the columns, and the connection forces in the corner connection, my column to beam connection. What I'm also looking for is a stability analysis, a stability check. So I'm going to perform a separate calculation. If I go to calculate and I choose stability analysis and choose the required shapes that I want. So I just put 2 here and click OK. My calculation is done, and I go to new result and see stability analysis. Here I'm looking for the critical parameter, which, if it is above 1, then my structure is stable. If it is below 1, then it means that my structure is unstable, as is the case here. So it's to check the stability of the structure. These are the two the things that I want to look for: the critical parameter for the structure and the stresses in my plates. There's questions, and Dennis is working hard to answer them. Hope you're doing okay, Dennis.
Yes, I'm doing good.
Good. That's what I wanted to show you, and we can just stay for a little longer to answer any questions that there might be. And of course, Dennis, if you have anything to add.
Yes, I'm fighting.
Yeah. You can use this method to model your portal frame, and it can be used also to model different kinds of portal frames and different kinds of connections. You can also model some bolted connection, for example, up here in this knee joint. You can use point-to-point connection and simulate those bolts. So you can model different kinds of portal frames and different types of connections using this plate method shell model. Maybe that a bolt connection could be the topic of another webinar.
Okay.
Yeah, normally.
Flavio,
Ahead,
can I
Dennis.
take over?
Yeah. Yeah, go ahead, Dennis.
Do you hear me?
Yeah, I can hear you.
You can hear me, but can everybody hear me?
I think so.
All right, good. I got a question here from Pierre asking what is the design load with regards to web buckling for this structure. The design load is actually, if you imagine you put a load of 1 kilonewton per meter, or 1 kilonewton point load, whatever, then your critical factor on the stability analysis, if the critical factor is 1.5, your critical value is 1.5 times your load, which was 1. So your critical load will be 1.5 kilonewtons. So the result you get from the stability analysis, you just multiply with your load combination loads. So this is your security, your safety factor, if you'd like. There's the stability checking. Yes. Ananasios asked here that in this model, the stability analysis came up with the result 0.2. This means it is not stable. We have a buckling problem. You can, of course, if you have more restraints, you can, of course, add them, or you can go up in dimension. So, yeah, that's the way to move forward. But with this method, you can do all kinds of structures. It's not limited to anything. You can do everything. So what we wanted to show was basically how to model with shells, which is very, very easy, especially if you have an AutoCAD drawing before. And next time we will make now it's just welded together, everything. Next time we will focus on how to do the bolts, how to do the welds with line-line connection and point-point connection. Also talk a little bit about peak smoothing, where we have the bolts to avoid getting those nasty peaks. So this is the next step. So definitely we need to do something about this structure to make it hold. Pierre, he asked, what is the point of this method? You're right. You cannot design the structure. It's just to make an analysis. This is not for frame structure like this. Maybe you can just do bars. But if you have some facade plates where you're going to connect some balconies or stuff like that, you can do all kinds of things with these shells that you cannot do with bars. Also with the shells, you get all your forces in your welds. You don't do that with the bars unless you have one of those solutions we have implemented in our steel joint design. So it's just to show you can also in this kind of structure you can make holes in your plates for pipes or yeah. So right now they're just massive, but you can make all the holes you want, and you will still get an exact result which you cannot do in a bar model. So it's for two different kinds of analysis problems. Giuseppe, I'm not completely sure what you mean here. There are two ways of doing these. If you do bars, you need to have, and you do first order, you need to have your buckling length. But if you do it like this, you don't need buckling length. You need a stability analysis to see all your column effects and all your buckling, your lateral torsional buckling problem. It will give you all the lowest values for this. So you have a stress analysis and you have a buckling analysis. That's two different things. If you want to add a splice connection to the frame, I would just model the splice and make a line-line connection to the frame if it was me. But you also suggest you can extract the forces on the specific location. You can make the section result. You can make the section result and see all your stresses along the whole cross section. But the easiest way is to just make an edge connection there. That is the easiest way. Then you can also send it to Excel. So now I would like to hear you about something. Would you like some more webinars about the steel? Is it interesting for you to see something with bolts and welds, stuff like this? Okay. Okay. We will arrange these. And Klaus, he writes to me in Danish that he would like a little information about how to model with the right center lines. But Klaus, you made an amazing Excel sheet to calculate this. Because if you model from A to B on a line and make it a shell, it will be 50% on one side and 50% on the other side on this line typically, if you don't play with the eccentricity in both ends. And it can be a bit difficult to calculate this eccentricity, but it can be done. Critical factor for whole building, yes. Bolt connection also be interesting, yes. The bolt connections, just keep in mind that if you do bolt connections, you just have two shells with a distance between each other, and you do a point-to-point connection. And the reason you do that is you get the forces out, like you get in kilonewton tension or compression, and you get your shear. So you get your forces out where you can design the bolt for this force. And so all force go through these connections. And the same with weldings, it's just line-line connections. So it is basically just connections. I don't know. Will I be able to take over the presentation, Flavio? The screen? Because I would like to show, we have Klaus with us in this webinar. I would like to show one of the models he did with the shell elements. This is a very, very nice model.
I have an option here, give keyboard and mouse. I'm going to try it.
Yes, let's do that.
You can go ahead and try. Yeah.
Do you see my screen now?
I know you have. You have access to my screen, so you want.
Okay, I don't want that. I want you to see my screen. Let me see here. I cannot. You can make me a presenter.
Yeah.
Yes. Yeah. Now you see my screen, right? Now you should see my screen.
Yes.
Do you?
I do.
Okay, I assume the rest also do that. This structure was actually made by one of the attendants today. You can see all the this structure is loaded with a moment around the vertical axis, and you can see the compression element is over here. We have the tension element over here for the rotation. You can see the buckling of the plate, and all these small plates are modeled with squares, and you have point-point connections. This is all the bolts. So it's a very nice structure here. I think. I don't know why I cannot move this one. Go away. So this is just to show you examples what you can do with these shells. Of course, in a normal frame, you might not need them, but if something like this, you definitely need shell elements to design it also in steel. Jamal asked how long time it took to calculate the model. This I do not know. It also depends if you have nonlinear connections. If you calculate it just linear, I don't think it will take that long. We normally have much more elements in a building than we have in this structure. About an hour. But Klaus, an hour, it's I think this model is maybe 2 years old. I think something happened with the computer. So I would bet that we can do it now in 20 minutes or less. 5 years, yeah, Klaus says. So it's a long time ago. It was when Klaus was young. Giuseppe, if you run a second order analysis, no, you cannot set up buckling length in shell elements. That you cannot do. In next version, we will have buckling length for the concrete walls. You can define and set it together with shell elements to do a first order analysis of a shell element with buckling length. But this is in fem-design 2017, which will come in hopefully in December. So it's not something we have today. That will come together with a plasticity in the model. Jamal, yes, you can just an end connection, like an edge connection. That's the same the same as a line connection, basically. So it's the same tool. A line is just used when you have a distance in between. If you don't have a distance in between, you just go edge connection. Okay, it seems like there is no more questions. Do you want to wrap it up, Flavio?
Yes. Thank you all for attending, and keep an eye on webinars. We will send invitations anyway, but new webinars that will come up soon. And visit our website, StruSoft.com, and apply for a trial to test the software. Thank you all for attending. Yes, thank you for this webinar, and I'll see you next time. And thank you, Dennis, as well.
Okay, no problem.